Now we will start our new topic, carbenes and nitrines. So as we have seen already, we have studied different reactive intermediates. Okay, so out of that one, we have studied reactive intermediates like carbocations, carbanions, free radicals also. Okay, so we have finished almost carbocations, carbanions, and free radicals as a reactive intermediates. Now, next reactive intermediates are we have that carbenes and nitrines. Okay, so in this topic we will see what are the carbenes and nitrines and its reactions. Okay, so these are the so our topic. Next one, carbenes and nitrines and its hybridization. Here comparison. So review of carbon valencies and hybridization. So here you can see in methane hybridization sp3, methyl anion. Okay, so sp3 hybridization again, methyl radical sp2 hybridization, methyl cation, that means in case of carbocation sp2 hybridization. And carbenes are neutral highly reactive species containing a divalent carbon atom with an electron 6 state. Okay, so we have seen all hybridization of all these reactive intermediates. Now carbenes structure. Okay, here is the singlet carbene, this one is the triplet carbene. Okay, so there are two types of carbene, singlet as well as triplet. Hybridization of singlet carbene is sp2 hybridization, hybridization of triplet carbene is sp2 hybridization. Geometry of singlet carbene bent as well as triplet carbene is bent. Okay, SP containing one more carbon is there, triplet. We'll see now what is that part. Okay, so next, what are carbenes and nitrines? Okay, so nitrine also you have for study. What are carbenes and nitrines? So structure of carbene you can see over here having total six electron pair, six valence electrons. Carbenes have two are from this bond, two are from this one, and two are from this lone pair. So it's neutral, divalent carbon species, divalent carbon species. Okay, only two bonds are there containing six valence electrons. That is carbene. Nitrines, neutral monovalent nitrogen species. Monovalent, that means nitrogen should have only one bond containing six valence electron. Okay, in both cases we have six valent electrons, one, two, three, four, five, six. Okay, so these are the structure of carbenes and nitrines. Both are electron deficient species, and due to electron deficiency they are unstable, and due to that instability they are highly reactive. Okay, reactive intermediates, highly reactive. Next, what is singlet and triplet carbene in chemistry? Okay, so they are very short fluid species in which one carbon atom possesses two bonds and two non-bonded electrons, either paired or unpaired. That is, carbene is called a bivalent carbon compound. There are two types of carbene: singlet carbene and triplet carbene. Very important type. What is singlet carbene? The two non-bonded electrons of carbene may be either paired or unpaired. When they are paired, then the carbene is called singlet carbene. Okay. So this is the presentation of atomic orbital presentation of the carbene, in which you can see this is singlet carbene, MTP orbital, non-bonding electrons paired in this sp2 hybridized orbital. sp2 hybridized orbital, both that is the pair of electron, it could be paired or unpaired. Okay, so now in singlet carbene both electrons are paired, due to that we can call it singlet carbene. Now what is the scene in case of triplet carbene? Okay, so what is the triplet carbene? The two non-bonded electrons of carbene may be either paired or unpaired, but in triplet carbene they are unpaired. Here you can see both electrons, they are present in different lobes of hybridized sp2 orbital. Okay, so in triplet carbene electrons are unpaired. Okay, so that is called triplet carbene. Carbenes. Electron structure, carbene configuration, triplet versus singlet. What is the bond angle and everything? Triplet, two unpaired electrons. In triplet, two unpaired electrons. In singlet, all electrons are paired. Okay. Often has radical-like character. Often has electrophilic or nucleophilic character. A-type amphiphilic. Okay. Nitrine here, nitrine. So what is nitrine and what is nitranium ion? So nitrene singlet, okay, nitrogen having total 6 valence electron, 1, 2, 3, 4, and here is with R 2 electron, okay, total 6 electrons. In carbon also total 6 electron, 1, 2, 3, 4, and 5, 6, total 6 electron. So check out for total 6 electrons, okay, all electrons paired. Here in nitrogen there is nothing paired, non-paired, nothing. Here nitrogen has two lone pair, so all these electrons they are in paired form. Okay, one lone pair is present here, one lone pair is present here. And when nitrene on protonation, it gives nitrenium ion. Okay, so one of the lone pair is getting utilized by this H plus to form a nitrogen hydrogen bond. Okay, so this is nitrenium ion. Nitrogen possesses positive charge. Carbenes. Okay, again, a carbene is highly reactive species. We know that containing carbon atom with six valence electron having general formula RRC double dot. Practically all having lifetime considerably under first second. Okay, only 1 second it has lifetime for 1 second only. Structure and bonding singlet, triplet, and another form of triplet. Okay, so orientation of these bonds. Total spin 0 for triplet. Total spin 1. Bond angle for singlet carbene is 102 degrees centigrade. It's a paramagnetic, may be observed by electron spin resonance spectroscopy. Okay. Next, singlet and triplet carbene. Singlet carbene, singlet nitrene, triplet carbene, triplet nitrene. Okay, let's see. Okay, it's interesting. sp2 hybridized carbon atom, both singlet nitrene, sp2 hybridized carbon atom, in triplet carbene, nitrene question mark they have written. Non-bonding electrons have opposite spin. Okay, in singlet nitrene and carbenes, non-bonding electrons have opposite spin, occupy an sp2 hybridized orbital. Non-bonding electrons have same spin. Okay, they are pointing in the same direction, occupy an sp2 and p orbital. Okay, so hybridized sp2 and p orbital. xcy bond angle 100 to 110. Okay, xcy bond angle 130 to 150 degrees centigrade in triplet carbene, and this bond angle is in singlet carbene. Relative stability of singlet and triplet carbene. Which one is more stable, which one is less stable? Triplet is more stable than singlet when R is equal to H or alkyl. Singlet carbene here, triplet carbene. So in triplet carbene is more stable than singlet by 8 kilocalorie per mole, unless added stabilization possible. Okay, X is equal to oxygen, nitrogen, sulfur, hydrogen, etc. If we will replace R by X, then maybe there could be the different stability we can observe in singlet as well as triplet carbene. Comparison of triplet and singlet carbenes. Spin state in p orbital, in sp2 orbital, in sigma orbital, singlet carbene, triplet. In most cases lower in energy, Hund's rule. So triplet carbene is more stable. Okay, so by taking into consideration spin state also, we can say that triplet carbene is more stable due to lower in energy, as according to the Hund's rule. Geometry we have seen from X-ray structure. We know that both singlet and triplets have both are bent. Bond angle triplet carbene, that means they have bent geometry. Triplet carbene bond angle 130 through 150. Singlet carbene 100 to 110 degrees centigrade. Next, triplet carbene generally stable in the gaseous state, while singlet carbenes occurs more often in aqueous media. The carbon atoms in singlet carbene is sp2 hybridized, in which the spin paired electron occupies sp2 orbital. Shape of carbene is planar. Triplet carbene. Why triplet carbene is more stable than singlet carbene? The stability of carbene depends upon their electronic arrangement. Okay. Triplet carbenes have two unpaired electrons in p orbital. According to Hund's rule, 3a multiplicity is possible, whereas the multiplicity of singlet carbene is 1 with the paired electron. Besides, triplet carbene has 33 kilojoule per mole energy, which is lower than singlet carbene. For the above two reasons, triplet carbene is more stable than singlet carbene. Preparation of carbenes. Carbenes are formed by the photochemical decomposition or pyrolysis of diazomethane or ketene. Okay, so diazomethane here you can see Pyrolysis of diazotine. Pyrolysis means heating at higher temperature or decomposition. Photochemical decomposition. Photolysis, which leads to the singlet carbene. Singlet carbene again on treatment with HNO, it gives triplet carbene. So in this way we can prepare carbenes. Carbenes are also formed by elimination of alcoholic chloroform solution. So from chloroform, okay, in presence of methanol, we can synthesize carbene here first, and this is on further treatment gives singlet carbene, which has total 6 electrons. Generation and fate of reactions of carbons. So how different ways how we can generate the carbons. Disintegration of diazolcanes and their analogs via photolytic thermal or transition metal catalyzed routes. Okay, so different routes we use to synthesize carbons. Diazolcanes are here on photolysis pyrolysis. It gives this carbon. Again, this kind of compound on pyrolysis use carbene. Again, such type of compound again on treatment maybe photolysis or thermal or transition catalyzed routes it gives carbene. In case of transition media catalyst, we can generate such type of carbenes. Okay. So different routes are there to synthesize carbenes, carbon formation from diazolcanes. Okay. HNO or heat, we can get carbene. Sulfonyl hydrogen, we can get nitrene over here. Sorry, it's carbene or nitrate. It's carbene. Halides from halides we can synthesize alpha elimination CCl2 as a carbene. Base induced elimination to get carbene. Okay, we have to eliminate this one. We can get carbene, CCl2 again carbene. Again, from such compound, we can get such type of carbene. So carbenes in which name reactions involve carbene as an intermediate. So that one is Wolff rearrangement. So for study, we have to go through different name reactions like Wolff rearrangement and all. So different name reactions involve in carbenes. That PDF format I will provide you soon for regarding to study the carbene reaction. Carbene being the electron deficient species may take part in electrophilic around substitution reaction, for example, in the Reamer-Timmer reaction. Okay, so Wolff rearrangement, Reamer-Timmer reaction, and so many more reactions which involves carbenes. So addition reaction of carbene here is one example of addition reaction of carbene. How we can synthesize cyclopropane, halide formation via carbene. Carbene we can use to synthesize halide. Okay, negative charge, positive charge on adjacent carbon heteroatom. Insertion reaction. So we can insert carbene in between these two X and Y. So here we got this type of product. So different things we can achieve with the help of carbenes. So detection, how we do detect carbene? Like in free radical, we can detect free radical by ESR spectroscopy. Electron parameter resonance spectroscopy can be used to detect the formation of triplet carbene. Okay. Rotational fine structure of the UV and visible spectra detect the formation of singlet or triplet carbenes. Fine suction reaction can also detect and distinguish the formation of singlet and triplet carbene. So next things that different reactions which are involved in carbene synthesis that PDF file I will provide you for your further study.